Hi and hello. Welcome to the lab. So the last couple of videos we did. We are finally ready to start working on our core scanner generator library, and yeah, get straight into it. I suppose a lot of things to do. But I won't put everything into one video. I think it's too much stuff. So. In previous videos, we worked on a simple logging mechanism on a either type for error propagation, on list type, and of course a simple string view, and also on this little data class, which just holds specifications for tokens, which we are going to define in our scanner. So basically, I want to do something like this. I want to say, okay, have a scanner specification, and then add some tokens, and I give it a name, and I give it a symbol or a keyword, for example. Could also be. So the idea is that there are two kinds of tokens. I'm calling them literal token, regex token. The literal token. So basically, regex token. Basically, literal token is a convenience way to add symbols and regex tokens. So basically, what do I mean by it? Maybe I will keep on the example. So let's consider that we have a program like this. So this program consists of a number, a space, plus a space, and another digit, basically. So and so since it doesn't matter which number you write here, you have to have a way to describe different kind of tokens with a that are similar in structure but different in content. And well, you use regex for this, so you can describe any number by a very simple regular expression. So in common regex engines, also /d I think is possible for digit, but I to be explicit here. So, and of course, the plus singleton token, it has only a single value, thus the plus, so the content is not. Yeah, so it is always the same content. The content of the literal token, of the token I call literal, which I specify as a regex token, content can change. So meet Bibi, my second cat. First cat was already in a previous video. So she just woke up. She slept here on my desk. So okay. So, but I want to be able to specify a scanner like this, currently only in code, no file format, or no way to include it somewhere. But well, maybe as a second step. First of all, yeah, I would like to specify it and then compile it to a real scanner specification. So to a scanner grammar is a thing, so to a table or to some data structures which describe how to create a scanner. So so there is some things to do to be able to generate a scanner out of such a specification. Because the overall structure is not really that not that hard. So first of all, you have the specification as we have here. Then you typically build an automaton out of those specifications. So each token gets its own automaton in the first step. Then they are all combined. Then you have one big automaton that able to detect a single token. No, not a single, but all tokens. So it has different halting states, and each halting state is associated one token basically. And this automaton then gets minimized typically. So, and basically this is what we do. So what I now want to do. So maybe let's just put it here. So we are working on this method. To work on this method, we have a couple of steps we need to do. First, create. So the automaton creation is done in 2 steps. You can do it in 1, but the algorithm to turn regular expressions into state machines is quite sophisticated, and I'm not going to do this. I want a very clear process that is easily testable, and yeah, so I'm doing it in 2 steps. So I will first create a non-deterministic finite automaton. Since it is very easy to compose them, you don't have to keep track and handle invariants. So it's really easy to create a lot of small ones, combine it into a big. Then we return how to do this. Convert the NFA, so the non-deterministic finite automaton, and so let's use abbreviations. And the next step, we turn it into a deterministic finite automaton. So then we have a DFA, and then what you can do, but you don't have to do, but I'm going to do, you can convert the DFA to a minimized deterministic finite automaton. I have to practice how to say automaton. So you minimize the DFA. So and then I'm calling the minimized thing MFA just to differentiate between them, but it is still a deterministic finite automaton, but has less states basically. And then once we reach this step, this automaton can be used to, for example, generate a scanner generator C file or a table, which you can use to simulate a file. So but I think the next few videos are quite heavily, so maybe not the next ones, but let's see. I think we will start with creating NFAs today, but not for all cases. So we just look at the simple cases, and we have to, well, how to say this? So I think we have to deviate from our automaton way to be able to turn regular expressions into automatons. But this is the approximate way we're going to implement this. So very high level view, of course. So, and I think we're going to jump straight into it. So, but first, I again forgot to commit the changes from last time. So let's just do this very quickly. So I haven't actually pushed anything yet, so I'm just going to amend the changes of the list into the original commit. Then I renamed the log1 function. So this can be a separate little change. So I don't commit the changes in the main file. I think I have to do a little break and play with my cat. Let's see. Okay. So this data class holds information about the tokens consumer of this focus. Generate scanner. Let's just keep it short. Oh, I have to close the window. One, please. For that, I think we are fine. Yeah, okay, sorry. So now this out of the way. Now I'm going to create a new class that I'm calling grammar, I think, and just going to add them to our demake or grammar. So dirt. So I only want one piece of public API. Of course, I will wrap it into my namespace called sigil. And I have one public method that I'm currently planning to. So of course I will implement since so basically I'm just hacking this signature. So I'm just going to, for now, use a string view, communicate errors, just as a dummy. We'll replace it by a more sensible error code later. So in the specification, I think I will just include it as well, not signal.h, but the sigil specification. So since if you want to use this method, you probably have already implemented or included this class. So I'm basically aiming for this method signature. I like it. I really like it. So everything else will go into the C++ file, I guess. So auto-generated code doesn't work. So I want let's implement it using a dummy implementation. Let's stub it out. the problem? Ah, yeah, the closing parenthesis. Okay, builds, and so now I'm just going to, oh well, I just keep the print, I guess. For now, want to do, now I'm going to include the class grammar, and I'm just calling it. So grammar compile specification. Step, of course, spec. So like this. And then we get a either grammar deck. Either grammar. So, and then just to be sure, we check the result, and if we are invalid, we say, okay, log print error, either left, either grammar, I called it, and then we will just exit failure. So if we were successful, we have a grammar, so I'm just going to extract it, remove either grammar, please write. So in this case, we are just going to create a breakpoint for now, and so let's just remove. No, let's keep the move and eat the warning, and I think let's keep it. It's just our test code in the. So of course, if we run it now, we should get our not implemented error, since our compile method always returns an error with not implemented. So okay, so now let's simplify. Let's for now just no, perfect. Let's plow right ahead. So maybe let's commit what we have already. So just as a stub. Also, I'm guessing that I commit main file, that I don't have to retype this every time. So just for now, basically. So stub out sigil grammar compile. Okay, nice. So okay, now I don't need this include anymore, since grammar this, but I don't like this actually, since I am using specification and grammar. I like to include this class as well. I know it is, well, I don't, so let's just ignore it. So okay, now huntings. Now, how do we want to represent a finite state machine, a non-deterministic finite automaton? Needs more practice. So let's just, I want to call it a short non-deterministic finite automaton. It's really long, but this is really short. Let's just but this is maximally clear. Let's use the long name. Well, no, I hate myself. I have to retype this every time. I think I will just call it NFA. much shorter. So let's hide the, I don't know why it shows me the copyright header each time. I know what my name is, and I know that I'm specifying this. I don't know why it forces me to look at this ugly code, this ugly comment every time. So, and our non-deterministic finite automaton. So what do I want to do? So let's start with a simple case. So do I have a paint-like tool? So I have Windows Paint, but I also have my paint. Oh, I have Krita installed. Krita, or however it is called, pronounced. Just going to say Krita for now. So it's loading. Cheers. Have some water here. So here it is. Yeah, just create a new file. So, so let's say we would want to pass a. So basically, we now have to have two different tasks. Our first task is to turn literal strings, basically literal strings into automatons, and also regexes. What is the plural? Regular expressions. So so first we will concentrate on symbols and literal strings. So let's say, oh, this is really big. Well, okay. Let's say we have the string if. So really professional. I'm drawing it with a mouse here. So if we have the string if, this string basically represents. So how do I change the size? It's big already. Here it is. Okay. So it basically, you can detect or recognize such a string by the following automaton. So basically we have a start state, call it 1, and then you see an I, and then you get to the next state, and then next state, and basically this is the start state. I'm noting this by an arrow that has no origin, and this is the accepting end state. I'm noting this by underlining this. So basically this automaton, for example, if you get any string and start this automaton, you can see if the string I gave you starts with this string using this automaton. And such automatons we are going to generate now. And first of all, we're just going to do this for simple strings, so for literal, the tokens that I'm calling literal tokens, so which are matched literally in your source file. So this is the same for for keywords as well as for symbols. So for example, if you have the literal token plus, similarly you get a state, basically one transition which carries information. This automaton, you have one transition for each symbol in your literal token, and basically you have one more state as transitions for each literal token. So, and this is what we're going to do now. And I think I can't really remember if if this is enough. So basically we need to know which state is the first state. Now we need to know which state is the accepting state. And I think we are going to support multiple accepting states, but only one start state for our NFA. So how do I do this now? So I think I'm just going to model this picture. So we have this, everything is our NFA, but then we have a state. Does it need any information? I think it doesn't, because I will have a pointer which I uniquely identifies as state. We just need the flags if we are a start state or accepting state. So let's just not suffix everything with state. We're already in the class called state, and accepting. So now we have states. So now we can represent this error, this underline basically, in the circles. Now we need the transitions. How do I want to store this? Do I want to store this as a graph, or just as a list of states and a list of transitions? Because each transition also needs payload. This is the accepted character. So this arc basically. Oh, I forgot the arrowhead. So I think fine to start with. Also, always get more fancy later. So let's also introduce. I think I will namespace this A. Since then I have a NFA state and can use. I'm thinking then I can flatten this structure a little bit. So of course now everything is private, but I'm just modeling the types classes here. So and then we have an arc, which is basically every error where I have some meta information. So this is basically what we have now. Am I forgetting any? Okay, so now let's think of, so basically I want to reuse this class as well as for the simple transitions as for the complex ones. So let's imagine we have an automaton. So we have here two automatons which simply represent single strings, which we have to match literally. And those are trivially to create. But later on, we are going to generate automatons for regex, for regular expressions as well. And there You could, for example, have something like this. So let's keep it simple. The automaton for this could look something like this. So we have a state, and you can select an A to Z. So I'm not drawing 27 arrows now. I'm just going to keep it simple and write down A to Z. So this could be the automaton for this regular expression. We will create it later, but for now, we take it for granted. So, and now basically if we combine those three into a combined one, just on paper to start with. Oh, I found the shortcut to change the size. So I switch the color, switch back. So. Okay, so now to combine those, we basically do something like this. We copy the automatons down. Yeah, maybe I copy them really. So basically we do the following thing. We copy the automatons, doing it a little bit. Well, can I just copy regions? That would actually be a lot easier, faster. I just copy, paste. How can I move? Is there a move tool, or how can I just, yeah. Okay, now I copied everything. So fine. This is fine. Not what I wanted to do. Well, I did, I see what I did there. Didn't select this. Is there a, this is a selection tool. I get it now. So now I have copied this. So now where's the move tool? So I haven't worked with it a lot. So so now can I join? Yeah. Oh. Do I have to accept this somehow? I have to accept the paste. Okay. Okay. Now, how do I remove the? Okay. Now, can I now draw again? Yeah. Okay. Sure. So, yeah, and to combine those, you copy them basically, and then you just invent a new state, which now is the new starting state, and you then just connect those labels to the existing start state. So I chose 4 here deliberately. So now I should rename the states. So 1, 2, 3, 4. So let's just number them through 5, 6, 7. So you copy them, rename the states. So I don't really need to do this since I don't have, my states don't have numbers attached. And you just invent a new start state and connect the labels. On this arrow, I will label as epsilon. So this is alpha. I tended to write epsilon. Just means nothing. So I don't need to consume a character to do the state transition. So now basically I have the combined automaton, but now we have to keep in mind that this state was introduced by if, the pattern if, by the token if, and this one plus. So parentheses, and this one basically the regex. So we just have to remember the token. So now we have a combined state scene. But I don't see my problem. So why did I tell this? Why did I explain? This is what we are going to do. So basically what I think I intended that you don't only have single characters, those transitions, but also ranges. Also, you could have potentially ranges with, how do you say, with gaps in between. So for example, A to Z and A to Z, for example. And you can also support epsilon. So I think this is what I wanted to say. So we have to invent a way to describe those sets, or this different range, these ranges, plus epsilon. So I will just invent something new for this. So let's say so the easy case is epsilon. This is the easy case, of course, and the epsilon is just a flag whether we position out and without seeing any character. And theoretically, you could also imagine that we have plus and epsilon here, so that you can transition this state to this state when you see a plus, but also spontaneously, basically. So I don't know if we need to actually model this behavior. So I don't know if you either have an epsilon or a character set, character ranges. Okay, so then we have some information. So I'm just going to write down, invent a way. Track classes. So maybe we're just going to model this now. So let's just call it char set. Char set. Let's just a bit simple, I suppose, and let's just invent a new class called char set. Going to this into digital. So yeah, so char set. So a char set, in my eyes, could be such a thing, but without the epsilon. Just multiple ranges. So, and I think I'm going to, for now, the most stupid thing I will say, so let's start by making this a little bit more concrete. So I will include core types, then I will just put this into the name sigil. and for now I'm just going to define the empty constructor and maybe the constructor which takes a single character and also a constructor which takes a char range. So first, last, let's do including, so inclusive range for this. So those constructors, that's for now just most simple thing. So that is, I will encode this as a Boolean array. So included or something like this, and I will just array of Booleans, and thus, so this character set will hold a ASCII character. It can encode every ASCII character. So since character can only hold 8-bit values, so maybe let's drop in a to-do to don't forget this. Also support non-ASCII character. But this is not what we're going to do today. So we will just initialize this false, and then implement those structures for now. And now, to see if a character is in this set, the function. So, but maybe let's just build it when we actually need it. So maybe just the types for modeling this behavior. So so when both are included, so I think I can then just initialize this by this. Then I have to implement just one chapter. So then let's just implement it, since it will be really easy. So call it first and last, and let's just go through the character range. So less or equal than last, then increment C, and we're just going to mark them as included. So I think I fucked up. So so I need max value. I see. This is wrong, since size of characters 1. I used the wrong so numeric limits has this. Numeric limits of U8. Just explore static auto size. Let's just remember this. So character set. Now, of course, I have to add to my CMake lists. I'm going to do so. Grammar. Let's actually sort it by alphabet. So char set is of course the first class, and it starts with a C. So now I already included types, but I need to include numeric. Oh. Where is it? Oh, limits. I remember now. Limits. So now this should compile. Oh, charset compiles, but yeah, of course it's a really dumb class. So I'm going to mark it explicit. Okay, so now I have everything I need to. So I sketched out this label on the position. So this is our character set. So let's add NFA to our build. So does it compile? No, it does not. Since I have to include sigil, no, not sigil, charset. Oh, and now. So now I think I rename this to Automaton. Since now I can then include NFA state, NFA arc, and NFA automaton. There, of course, the A stands for automaton, but I think it's quite a neat way to differentiate different states. But because maybe we might also have an DFA state later, so it's internal API nonetheless, so I can just plow ahead. So states, arcs, and the automaton. So now I have to allocate those things somehow. So how do I want to do this? So I can just create a list of those things, but pointers are not stable. So if I put the states in my list, I can't refer to them since we are reallocating. So I think I have to store pointers. So how do I allocate states automatons? So maybe I will create functions for this, methods. So then how do I do this? So the automaton. Of course, I want to have a API like this, returns a. Now I want to identify them by pointers, I think. So create state. Then of course you then have to somehow tell it is start state or an accepting state. But you get the pointer, a mutable pointer back. Don't I want this? So I am how I want this. So maybe you specify, maybe I will do references and const references. So then internally I can allocate. Then you can just, yeah, I see. I know how I want this. Oh. Oh, maybe just booleans are fine then. But what if I don't want to do this? So of course you can create a state. Then you can somehow have to give it those meta information, and then you can create a transition, which I'm just calling arc. Or should I just call it connect? Yeah, no, just create arc. And it takes in 2 states. And then I suppose some labels. So I think I will invent something that I can have nice calls to this API. Ah, well, maybe not. Or maybe I will just give out a mutable reference, change it later. So I will do this. Then, so you can just create a state and then configure it as you like. So same here. So, and I think I need to attach information about which token to which token this no, I think I don't want to do. I might do this externally. So let's build something like this. So let's build it out. So I have a public API and of course also a private API, and it's well, didn't want to paste this. Now it did work. So how do I just want to let this, let's just use structs for now. Everything public is fine. Doesn't need to be perfect. So just for those classes. I think it will be easier to work with. But let's see. So yeah. Now Automaton needs to remember those things. So I will just create a list. Remember a list of states internally, and also a list of arcs. Oh, not args. So then we need our list. So and maybe I will do something like this. We'll just, for good measure, define the constructor, but the default constructor is fine, but I will create so the default constructor is fine, but the destructor, those methods will allocate. This needs to clean up memory. So the class is now called NFA. Well, so I don't like that this class and this, not really, but this basically defines the namespace NFA. I don't want to lowercase classes, so files. I'm not really decided on those. But yeah, so So we have our destructor, which doesn't do anything yet. And implement those. Just stop it out now. So basically, the destructor to destroy everything what is in a list. I'm going to loop through everything in states, every state in states, and if when the state is 0, if the state is 0, we'll just skip it, and if it is not 0, we then just delete it. Just very basic. Maybe we don't want to delete to allocate them one at a time, but then we will just replace the construction and the destruction. So let's keep it simple for now. Let's not introduce more concepts. So in here, I will just create a new state on the heap. Add it to the list. Then I can just return the pointer. And this pointer is basically stable since I allocated separately. So even if I roll this list in the future, it will be fine. So the arc I will remember the original state. So the origin and target state, will remember them. Okay. So then auto arc. So the arc so this should be fine. Now those values are set. So, but now can I reassign this? Can. So then I don't need this const, but this const. Don't want to be able to reassign the pointer. Yeah, sure. So I think like this. So then I just remember this pointer internally, just return reference to it. So then I have a nice API, and I can still configure the remaining fields epsilon and character z. So for now, this should be fine. Of course, we need to access the states and vary a different operations between two states, but for now, just create this. Okay. So now we have an NFA. Yeah. Okay. So the character set, not perfect, but should be fine. And the grammar. So let's go in our grammar class. Now I get past the specification here, and I now can vary my tokens. So now basically I have to create one NFA 1 NFA per token. So let's do this. Do I want to keep NFAs around? Well, let's do it. So now let's sketch something out. So basically, the grammar should contain every information that I need to know later. So let's say tokens. So let's say we copy the tokens. Let's do it. Token. Not like this. So let's figure this out later. For now, I think it is not really required. Once we use this to make something useful, or maybe for unit tests, I think I plan too much ahead. So let's just go through our list of tokens. So from our specification, we take the tokens. Each token we now want to create a NFA. So we can do something like this. First of all, I can include sigil NFA, and then I can remember all NFA automaton a list. Also, I know how many I need, so the tokens know the count of tokens, so we can just ensure the capacity that we have only one. Furthermore, we can also do it here, so we spare on allocation. Okay, sure. So now, so basically now I have to create a automaton for this token. So let's do it. Let's start. So I don't know how I want to propagate errors. Maybe just create automaton. So automaton. So like this. So now this is. So now I take in my automaton, and I take in the token specification. So how's the class called? Yeah. Token specification. Token. So, and now I will just return false just as a stub for now. And let's just do the differentiation already, literal So yeah, so then I don't pass in the token anymore. I just pass in the name. Let's just keep it everything. So oh, let's do this. But now I have to associate automatons tokens, so I will just create by index. So NFA and fine if I do something like this. I have I have the operator. So yeah, thanks. Oh. Okay, nice. So the idea is that how to delegate arrows. Yeah, so I think I have to tweak it once we return the error, but for now I will just say, so just during development I will say so let's just return our grammar. Let's remove it. In this case, we're just going to run a let's into the result type, which is just an alias for either, so that I don't retype this anymore. So failed to create token NFA for token. So, and then I have no possibility to attach meta other information, so I'm just using a breakpoint. So just to limit my scope now. Now what this problem is about. So basically I have to NFA so append, I have to add to automaton. Then I can access the index. Yeah, okay. This should fix this assert. So basically I'm just allocating enough, but I'm not really constructing any into the list. So and of course this method always fails. Okay, nice. Let's deal with this method. So let's do the following. Let's do the easy case. So let's switch on the token type. And the type is either invalid, literal, or regex. Let's hack something together that so those cases are unreachable. So, and in this case, I'm going to do the following. Case is not implemented yet. So I think I will just say that not implemented yet. Just for now. And I will also wrap this in braces. A little bit of space for readability. At least this is more readable for me. Okay, so now to create a literal, to turn a literal into an automaton. I lost the word, I'm sorry, the automaton. Basically, we have to create a dummy, a start state, and for each letter the consecutive next state. So let's do this, I suppose. So so if we are a literal, what do we know? We know the pattern. In case of literal, the pattern is just the string itself. So we have an automaton. So let's just create the current state. How do we do this? So first of all, I will create start state. Let's start simple. So then we will create a new state. So this is a reference. We flag our start state as true. So this is our start state. Then then we need a way to iterate through our thing. So how do I want to do this? So we have token.pattern. So I can iterate using a for loop. For each would be nice in this case. So let's add a to-do, introduce for each iterator for bring you in and bring you end. So I think it should be clear what I mean by that. So then we have an index which ranges from 0 to pattern size, and then we can at least extract the character. C is fine. So token pattern. Yeah, I don't really want to write this like this. Thanks, C++. I mean C line. So okay, this should be a character now. Perfect. Okay, so now the character. So now I have a start state. I can't I reassign a reference. That's just not really sure. I can do this. Well, in this case, it doesn't make any sense, but yeah, I can do this. So now I'm creating a new state. So let's say next automaton create state. So let's call this one current. So the first current is the start state, then the next is a new state, and then there's an arc current and next. Of course, once I'm done, I have to assign next to current so that we always chain follow the chain. So and arc, of course, the character set, I will just say it's a character set of this character. So very basic. Now this should create a chain of states connecting them by an arc, which is always the character we are looking at. And in the end, So the last current is the acceptance state. So I think this should be it. So in this case, we are successful. So basically, a string can't fail. Processing a regex will be able to fail since, well, can be tactically incorrect, but a string is a very easy case. So I think running this will fire this assert now. Yeah, grammar 36. Yeah, this one, this line, assert trigger. So maybe I will just if def the regex tokens out for now. I think now it should work. Let's just see if it runs or if it crashes. Okay, it seems like it crashes. Sorry, it runs, of course. Idiot. And now let's follow through. So let's, for testing, add another one, a longer token. Let's say a keyword for each. So we have something to look at. And let's just double check those two cases. So I will want to look at mouse. So in this case, I will also, so why does it require a return value? Since I don't return here anything. So now we have a return in every case. So this warning goes away. Yeah, and of course don't need the break here since I'm in every case. Okay, let's run this. So now this warning went away since this condition is no longer always true. So now let's see when we reach this method function. What did we get? We get a literal token, of course, that we did expect that, plus and symbol the pattern plus. So let's follow through. So we create a new state, which we're going to set to the start state. Oh, accepting is not really what happened there. So create state, new state. Why doesn't clear this? So I'm just going to hack it for now. So memset, is this key string? Yeah, okay. So let's restart and see what we get here. So we have current and accepting is still 26. Not exactly what I think yet. Oh, let's repeat this and look what we get here. So basically it is uninitialized. But I use new. Isn't new supposed to initialize this? Since, well, do I have to do something stupid like this? Is it now initialized? I hope it doesn't work like this. No, not really what I'm expecting. So do I have to define a constructor, a default constructor, since, well, I already thought I wanted default values. So what do I get back? Still crap. What's your problem? What did I do wrong? So I'm allocating in state. What? Why doesn't it use my default constructor? Well, and why didn't this work? What wrong? Can't be. Okay, let's follow this. So I allocate a new state. I get something back. Fine, okay. Well, it is initialized to false. Initialized to false. Then I memset still false. Add it to the list. False anymore. What? How can my add function? But okay. I don't have to do this. But I can't do this. So I think this destroys it. So I don't need to do this. This is stupid. My list is broken, I suppose. But what is the problem? So let's see. If I reach this method, so let's set the breakpoint here. Okay, now let's jump into the add method. Okay, I have a value. It is a pointer to my two booleans, basically. And I have four slots available. Currently my list is empty. Okay, so ensure capacity should not change anything. But now this one will destroy my value. This one is still, somehow this destroys my value. How can it do this? So this is a pointer. Const reference to a pointer, to a state pointer. So basically I have to do this if not trivially copyable. or something like this. So copy assignable. So if T is the copy assignable, yeah, else I'm using the in place copy operator. The case I'm just going to assign this, I guess. This we have to fix this move assignable, yeah. Else I'm using the move structure. I'm using assignment, but move assignment. So let's see. Now, does it still break? Yes. What am I doing wrong? So this returns the pointer, doesn't it? What? So I set pointer here. What is the problem? I don't get it. Seems like I overlooking something. So okay, now fine. Then I'm copy. This is just a copy. So size should 0. So it writes in the first slot. But this is just a pointer. Then it just increments the size. Okay, fine. But why does it destroy my value? Don't get it. Like signs, still a sign. Doesn't crash or something, but drags my pointers. Then again. So maybe let's look at the character set. False, 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 and plus should be somewhere should be true. I don't know the ASCII character for plus. Oh, well, you have a computer here, so 34, 40, 43, of course. Yes, one true. Okay, nice. So then So then we should have one accepting state. This one still looks fine. Just seems like the first thing. This gets more state. Oh, so I think this is a patient fault. Ensure capacity. Alloc. Okay. So why? So we want to allocate size times capacity. Okay. This should be fine. So we say capacity. So we are at our maximum capacity, but we try store one more. So then slice this by 4. 4 is not 0, so this is skipped. 4 was less than 5, so we doubled our old ones. Now we want to store the fifth element, but we say, okay, let's just allocate 8 elements. Size of times 8. Enough, really. Okay, so this crashes. This So I think we're actually looking at the keyword for each third index. Or we already have 3 states. Then it crashes. Or what the problem is, to be honest. We just remember, just reallocate. So is there a possibility this field doesn't get properly? So I should. So this constructor doesn't explicitly initialize. Well, I've given default value, so I should initialize. What's your problem? So add. We are here. So we're trying to add a state pointer to a list. Pointer was allocated here. Yeah, only call character E. Yeah, fine, but see it. Don't see what the problem is. Oh, of course it crashes. Oh, the breakpoint, well, well, oh, allocate null point. So that's just something that create a breakpoint. Oh, well, actually I'm stupid. I can say, just say data of data, and let's just re-execute. Okay, data is null. Why? So when does alloc return null? Alloc Stack Overflow might help, but also be a ability to alloc. Give me the documentation. Yeah, Werbung, advertisement. So I read the name, the word, and brain switched to German immediately. So return value on failure returns null. So if it returned null, then it failed. So data can be null. So it is null at the first allocation. So I'm working with dates. So the following. So let's say that I want to, so I know the amount of locations. So here I have I added a new automaton. Then I can, and access it from externally. So I don't want to add accessors. So this might be a very weird bug. So everything works fine till a breakpoint trap hits. Tell me I can't read this. A little bit of assembly is no problem for me. I should definitely work on reading it, but well, I need to see the registers. Well, not the registry. Those are not reg. So memset called. Don't know what the problem is. So here is the yeah, calling it also. So when can realloc fail? Let's just to be sure, is any list can be destroyed and when? So if we have a data field, we just it, of course, then clear it, and we set our size to 0 and our capacity to 0 just to be sure. So does it happen now? It seems like it. Oh, my cat is lying here, and he's snoring. So let's see. What is the problem? So it crashes. Why though? Why though? Oh, if I just run it, but don't debug, does it still crash? Yeah. Always. So first allocation doesn't like I can't store pointers in my list. But why? Now let's test it. So let's just keep our old name, and let's just do something stupid. Let's say have a test class which just contains well, I want a better name. Well, just some random data. So okay, fine. Now, oh yes, this is now. I create a new list, and I will want to store test pointers. Let's just call it somehow. So let's just list add new test. So let's add some test classes. Test instance. So let's see. Does it crash? This example. Does it already crash? No, it doesn't. but let's store a integer. So let's do a well, a character is enough. So and let's do a struct. So now I want to five list dot add, but let's give it some data. Okay, but now let's use it like this. Let's create an instance, add it to the list, and then do it. So log x time break. This is a similar way how I use the args in the NFA. So create a pointer, add it to a list, and return it, but as a reference. So, but should be fine. So this works. Maybe I have to do more allocations. Shortcut. So it actually works. So of course, my example is stupid, but doesn't seem to be a problem, at least not with the list. What do I do wrong? So let's look. So I create an instance, initialize to what I requested, add it to the list, and still 0. Okay, fine. So next iteration, I initialize it with 1, add it to the list, it's still 1. Okay, it seems like it works. So my list works with pointer, not the problem. What is the problem? Moving lists. I think moving lists is the problem. Yeah, this might be it. So what am I doing here? So I think this is it. This is it. So I'm moving a automaton here. So and think so if you don't create a move constructor, I think it delegates to the members. The members is move constructor and move assignment. At least I hope so. But I didn't specify one from list. Let's do it. So let's just do everything, I suppose. So we want a copy constructor. Want a move constructor. And we also want a copy assignment, a move assignment operator. So where is it? Let's put it to the destructor. So and this methods under the destructor. Fine. So what is your problem? What do you want? I think it wants no discard. No, not no discard, but so let's just implement this with dummies. Just mark that I want to have to do it. This one and want no except, yeah, sure. This one also gets no except. Okay. There you go, no except. This also wants no. A move always wants no. You want? Oh. So I can't remember exactly. When I want to implement a move and a copy constructor, there is a thing, rule 5. 350, okay, fine. But I want to explicitly, yeah, okay, fine. Rule of 5. Okay, I have to implement everything. Rule of 0, better nothing than everything. I see. Okay, so I remember I do this correctly, at least. At least approximately. So just double check. Copy and move constructors. So you have to check if you're copying or moving to yourself. I can't remember. Copy to yourself. So this is roughly this pointer, this compared to other, and I don't remember how to do this. So I think this is wrong. I think he's missing something. Yeah. Exactly. So you don't do this. So in both cases, both. I see. You never do this. Okay, sure. So then let's, because I have the copy constructor and the move constructor, the assignment operators, and I implement them using the same code, I will just implement it once. So copy, we copy here, an list, and there's a consume method that. So basically, what I now intend to do, basically I can clean up a little. So I would like to call copy here like this. So in this case, I would like to zoom std move other. So basically, it is behavior is implemented in method zoom, and this allows me to reuse it in this operator. So So the constructors, I think I will drop them. I will dummy stub those methods out, but I will keep those here. So I'm just going to do the typical check that I had to look up. So if I compare this to other, then I can copy here. So basically I would like to do something like this. Then just return this. Similarly here. So just in this case I don't want to copy here, but consume std move other. Fine. So now I just implement two methods. So copy here gets a other. So in this case is really easy. I think I can just do, so I have three fields, data, size, and capacity. So I can just swap them. So std exchange, I think it's a great solution. So I exchange other size. Yeah, 0 is a good size. But I think I will leak code. Now this. Oh, well, I will consider. So we exchange the size and the capacity with 0 in this list. I see. So, and also the same thing for our internal data. We will put null pointer there. So basically it is a new, an empty list. Let's just double check if our capacity can deal with it. 0. It gets initialized to 1 and then doubled until it's okay. So I think I can check back, since I don't know if this change actually did something. So I'll just revert this. So I introduced this during debugging. So in copy here, I think we will just clear ourselves and then just add everything. So do I have to clear myself? I have to clear myself. Also, I have to clear myself. But let's do it in the. So I will test everything. So I will clear myself. Then I will copy everything into me. So, and I don't want to do this here. So now clear. Let's introduce clear. Add. Access, begin, end. Let's just add clear at the end. Clear basically does the following. Just yoink this. Oh. Argument. So could I release memory basically? So the user also, he always the user doesn't want to release memory always. So let's just, oh sorry, I was one step ahead and can't clearly anymore. So, but I want to finish this. So let's just move the destructor. Let's just call clear here. And in implementation of clear, we just copy in the destructor code. So now if we call clear, everything should be fine. Here we are cleared and we just copy everything over ourselves. So basically we're just iterating through over the other list and just copying element by element, I suppose. So then just add element. So that is of course not really performant, but not my main concern right now. I just want to do it correct first. So let's see. Okay, so now we have a current. Oh, it looks much better. I think that was the problem. Yes. Okay, perfect. Whew. So maybe let's just commit the changes to the list. So introduce, what did I do? I used the copy and move assignment. Oh. Copy, move, constructors, and assignment operators. For list. Okay. Okay. So now let's continue. Now I do want to print my automatons. How do I want to do this? Do I want to logger thing? I think it is quite ugly since it has many lines. So maybe just a debug print method that maybe just a printer. So I have to find the start state. So can I have multiple start states? I guess so. In FAs, I think I guess so. So let's give each state a number. This will simplify printing them. So this should be easy. So let's give it, this was completely unnecessary. Let's give it a, let's just don't, I don't think we ever get so much state numbers, but let's just give it an ID. So now create state. Of course, the ID can now simply be size of our current state. So the first state gets ID 0, the next one 1, and so on. Be as straightforward as this. So now if we want to print an automaton, what do we do? guessing. I just noticed some problems. It is theoretically possible to, so maybe, so if I call this function with the same combination of states twice, I create a new edge between those two. Should be fine, actually. No, it is fine. We are currently defining a non-deterministic finite automaton, so everything is fine. So, but now I now want to print all reachable states. So that's just for printing or debugging. Don't know if I want to do this like this. So let's say we have a, I can't do this either. So I don't know if it is a good idea to print it now, because I have no functions, I have no methods to deal with my automaton. So I'm currently thinking how it can be done. So basically, I would like to print something like 0. So maybe then I would like to print the character set somehow. So for example, A to Z. Then you can reach state 1. And so I have to iterate, check which states are reachable or which transitions. And maybe I will just hack it. So yeah, let's just hack it, I suppose. Yeah, I think I will just hack it. So no worries, just let's get straight into it. So let's just specialize our logger for automaton. And to do this, we have to implement public static void log with our automaton, like this. And can't find logger. This is all right. Now it should find it, and now I could be. Hello. Let's name space for don't know why I needed this, but yeah, so I want a logger, so core logging, want my logging util. I have to check my phone, I'm sorry. Okay, sorry, so now so now I need a way to iterate my lists, so to access them, I mean. So Automaton. So let's just create a way to access for now. So state. Let's not copy them. Let's just find them by reference. And let's just so basic accessor functions don't need to say anything about it. Args. What? So let's just start with const expr, and I think I know this card, and I typed it. So perfect. Accessor function. So now I can just let's just begin. So how do we do this? So I can't, for example, format my strings that I'm printing. So let's just see. I want to print all states, then all reachable states, maybe indented. And maybe I want to print the state. Maybe I just introduce an helper function. So let's say block state. Well, overloading. Do the job. So let's accept a const. So this is really stupid. Using sigil, using namespace sigil. I just now say nfa dot fa. Perfect. Now to print a state. What is your problem? I'm missing a return here. Value. So to print a state, I have an ID, and I know if I'm a start state. Sure. Here you have. So okay, I know how to print. Blah 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 blah. Okay. So let's do it. Let's do something like this. If we are a start state, I put a little star, or start begins with star, maybe just in front of my name, and if we are an accepting state, I will put it in parentheses. Since start state can be an accepting state, they can stack the effects basically. So let's say if our state is a start accepting, then I log an opening parentheses. So then I repeat this 2 times. We are accepting at the end. Start, we are start state, then I print star. Now only the name, the ID is basically missing. And B is state. No. Yeah. So this is a single state. So now let's iterate through states. Let's print this. Well, maybe I would like to do something like this. I would like to logging. I want to log thing like this, then a line break. I will indent everything, and at the end I will print this, but no line line break at the end. So now I can yes, I will do this. So now I can just print let's call it log state. Just internal. So now I have the state. So now so first of all I would like to print it. So let's make a little helper for this. So log indentation. It takes a count or the level of indentation. That big. Oh, and so basically we log level spaces. Or let's use 2 spaces for. So now I can say let's log indentation of 1 first level. Then we log the state. Then we are logging all the reachable states. So for every arc and reach. So for every arc, if our arc, basically, so the arc has a origin and a target node, and we are looking at state. Then I will do something, and else we will just skip it. So now we have an arc between state and arc target. And now I can just print. So let's see, I print indentation, then I log the state, and then let's log, let's print a line break. So and then in every following line, for each arc, I will log another level of indentation. So send it one more time, but only if you actually need to draw something. I want to log three dashes and then the character set between. So to do character set and epsilon. Epsilon. Then I want to print space again. Now the target state. So log state arc target. Of course, helper method wants a reference. So and then I can a line break again. So now this one is removed. So let's just skip it for now. Let's see if it actually prints something. I think I don't call the print. So this problem. but I'm assigning reference. Ah, I see. So this is also a bug, I suppose. But let's just return pointers. So now I get pointers back. Okay. Then I don't need to take address of it. Oh, pointer here and pointer here. Then I have to, so current is a pointer. I have to access it, pointer thing, operate. Okay, this is fine, this is fine. Pointer, fine. So, was it built? It builds. So now I've created the automaton. So I now have created all automatons. Yeah, I guess. So let's just say log log. Let's just import logging thing here too. Core logging. This should now work since now I've created the log. So let's see. Oh, does it work? Oh, it works. Where is my plus automaton? Where is my plus automaton? I forgot to remove. So this is not the problem here, but I see a problem. So basically, I have to accept a list. So and we have a list of pointers. So this is templatized by type name t. And this basically does. Oh, and I'm forgetting the void. And this is basically the same as this. I'm writing through the elements of the list. Yeah, okay, sure. They are not null. I'm deleting them. At the end, I think I will just clear the list. Now we have a clear method. Let's just do it. Doesn't really require it, but so now I can delete all dates and delete all arcs. So this is the same crash now. So we are okay. Looks similar. So same crash basically. We're seeing the plus. Okay. So we have a plus in our list. So where are we? Yeah. Does it? I think it copies it. Well, I hate this. So my debug stuff copies the automaton, then it gets destroyed. So something's not really working with this. So again, this, I think this copies the automatons. But the automatons, well, they don't have anything except lists, of course. So I think this will delegate to the copy structures of my list. So yes. Please copy everything, print it, just to print. It is 1 million gigabytes, just copy it, everything. Copy everything. Hate this. Don't know how this does, why this doesn't work. Okay, so this copies my automaton. Why can't it just... Why can't it just work? So I think I have to investigate why this doesn't work, but now I will just hack it. So let's see. So this stupid thing, I will just kill it. How to do it? So let's introduce a static function called log. I will just call it log for now, which takes in automaton. So implement this directly and call it directly. And if I get this working again, I can just reintroduce a logger that just calls. So, and to log this stuff, basically I don't have this anymore. Don't have this anymore. I can just everything here. Didn't I use for logging? Not have forgotten this. I have forgotten it. Nice. Using core logging. So now I should be able to use this directly. So, and this, of course, now just a method on automaton, static method. So I pass in the instance and it logs it. So now I will expect a compile error. Yeah, exactly here. So automaton log. Now it should just error by reference. Cool. So then I have to directly log. So then I have two problems, two issues. Figure out why logger const working, and of course automaton can't be copied. This is our list. default. Okay, but now it should work. At least should it print. Okay. So now prints the basic structure, and we are of course missing the transition. But here we have an automaton starting at state 0, ending at state 1. 1 is the accepting state. Yeah. 1, there's no outgoing transition of state 1. This is why it's, well, empty. Everything else, yeah, basically it looks great. Great way to just visualize the automaton. So now let's fill out this. I will just how to print char sets. So yeah, here I have a similar problem. I don't want to copy those around, but I think I will introduce the logger and just hack it. So print a character set. How do I want to print it? Really, it should find the ranges. Find ranges. So let's just enumerate. But can be many. Well, you can always improve it, of course. So let's include our logger, and then we put in core a specialization for logger again for class, and our class is char set. The log function is log. So this is exactly the pattern that is not really supported. So I'm specifying char set here. I'm also doing this. The automaton class, lost the word again. It copies it, and unfortunately there's a problem in my list. Yeah, so the destructor of the list crashes somehow in some case. Why? This will always copy the instance, but I don't really care now because, well, it is a big object, but 200 bytes. But copy it every time. So, but if I fix this, I have to just to go through all of my specializations for logger, and then I can just re-add const ref, and it should be fine. So let's implement. So in the namespace core, we have a logger sigil char set. That doesn't return anything, right? Which is called log. So char set. Perfect. So now I need logging. So to log in char set. So basically now I have to loop through all characters. all characters in the universe. Oh, first. So, or maybe let's do it a little bit different. I don't really know how I would like to do this. So let's just say we have the first character in X, just std and numeric limits in, and the last character distance max values 8. Well, let's just use this problem. Sure. Okay. So now I could re-implement this, but let's get so those are just to iterate through the whole set of characters. It's just type which is one bigger, I suppose. A problem already. So now I would like to ask if a character is inside this character set. Since I need to ask this now, I can just add it. Index characters in index. Fine. So this one I'll implement. Problem, no discard. Okay, sure. So now I can out for sigil set first sigil set from first to last, including the last, we iterate, and basically if set let's change, then we accept character. So and accepting this fine. So let's just to I to make the version a little bit more accurate. So and then well, I could also implement it just here. So if we accept character, we remember if we are the first. If we are not the first, then we log a space, a comma, except other. So then we can reset the flag. Then print it. So, but there is a simple way to check if a character is visible. Let's look at the ASCII table. So visible is everything. So space is also visible. So 32 visible, 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 visible until have the extended ASCII code. Going or just no umlauts for you. So character base. If we are at least base and C also less than tilde, then we log the character. So, and I don't know if this logs it as a number. No, can't log chars. Do this. Add a logger for chars. Character. And let's also copy paste it. Format specifier C. Check it. Put it this sort of related. So let's see if it actually prints. I'm learning. Don't know the format specifiers all by heart. So I'm not printing. Let's do this for the NFA. Let's logging print our char set. Where I get my char set from the arc. So and then if arc is epsilon, then I can just print. Let's print another comma epsilon. For now, this should be fine. Let's run it. Yes, that looks good. Perfect. So why it doesn't seem like my main function is working? Because it copies it incorrect. So then also love So what happens if I do this? Okay, I'm sure I'm not able to use the log method. But can't I just say logger explicitly trigger this? Oh, this is not perfect, of course, but it's better than to hack something together now. Can't sit anymore. I want to finish this now. So let's see, what does it print? Perfect. Still not correct. This somehow looks weird. So let's see, how does it work? Oh, but it differentiates the number of elements. So something it's doing. So let's see. Is this the problem of this method? Let's set a breakpoint and run. Mouth space. What am I actually looking at? I'm looking at arc that transitions from but unfortunately it's hard to here. This was a plus, I think. So 43. So then I can skip a little bit ahead. So 43. Now this character will be printed. So this should return true. It does. This is the first. So we skip this comma printing. Then we reset this flag. So the character is in the visible range. So then, why didn't it print? Oh, because I switched those. Derp. I switched the operators. So let's see. Better, but still not correct. So C. Oh, this correct. I switched it again. So C is bigger or equal to space. And yeah, I see what I did there. Hello? Press the wrong shortcut. Now let's see, does it actually work? Okay. But now what is this? So the first character is printed correctly, but then I see. So this here. So if the character, we should print the character. So this means we should print it. This means print it as a character. So no, I fucked up again. So in this case, we print it as a character, and in this case, it is not visible. So let's print it actually. Let's actually print it as a character in single quotes, and in this case, we will print it as a U8. So I can just print the I again. So in this case, it is printed as a character. So for example, like this case, it is printed as a number, like for example 66. So, but of course, it would be false. Everything should be false except one field. Why are there so many characters that things are actually printed? No, don't know. Maybe array is not properly. Maybe I use a little bit different. So let's iterate through the global list. And if I shall be included if so maybe let's just accept it as a unsigned number. First of all, not as a character. Also here, this and this. And this. So basically a byte. Could rename it byte set, but doesn't really matter right now. So now if first less or equal to I, and so basically the same as below. I is less than last, but inclusive. So if this is true, then this element is okay. Well, oh, please don't cry. So this, I hate that this. Yeah, I know it shadows it, but I can also. I know that it shadows it. That's why I'm prefixing the namespace in the class. So perfect. Better now, of course, but character. So not really. This correctly. So do I have enough? So do I have to +1 it? So max value. But I have one more. Since I also want to store. Yeah, I want to use it as an integer. Max value should be a valid integer. So perfect. So now I fix it, and now recording a long time. So I'm getting really tired. So basically, this part is now working. The part above. So I can give it a string. For example, I used plus. So I'm using different names for states, but we have a state, which is the start state, and from this start state here, in this case 0th, we have a transition. When we see a plus, we go in the second state. This state is marked as accepting, so in this case it is in parentheses. So okay, yeah, and in this case it's just a chain like if, but I used the example for each. So we start at a state, we transition the next one, and it's always a chain. So 0, 1, 1, 2, 2, 3, 3, 4, 5, 4, 5, 5, 6, 7, 6, 7. 7 is the remaining, and there's no outgoing transition. And it's basically like if, only longer, with the keyword for each. So also, what I also would like to test. So one thing to test, and then I think I will wrap up. So let's introduce another token, which is just the empty string. Since in this case, our start state will be the end state of the generated automaton. So in this case, we have one state. It is the start state. It is the accepting state, and it has no transition. So Automaton creation works as intended, at least for simple chains of words. So here, of simple keyword tokens. Hello, hello, baby. So I think this would be a great wrapping up point. Bibi agrees, and yeah, I hope my rambling is somewhat important. And this one, I think it is nice to always learn things, but I mean, I do make mistakes and I fix them. But today I just wanted to get this code working, and yeah, maybe let's see how we continue. So of course I need to turn regular expressions into automatons, but I'm not really sure if I want to do this next time, or I think I will just clean up a little bit. So of course, there are a few bugs, a few things I can improve. For example, for in the logging code, maybe I do some research how to do this a little bit better. I think I have to do this because it sucks, the code as is. So, but before I forget, let's commit what we already have. So, 2 patches. We first use a logger for character. Oh, I already derped. So I didn't want to stage this part. Okay, let's do a commit. Introduce logger for class. So Bibi wants to show her face in the camera, fine, but I don't see a thing. So please, if you would like to sit here, dear cat, I would see the Could you please stay here? So then, I mean, could you please? I come to play immediately. Give me 1 minute, please. Import symbol logging into global name, something like this. So then what did I do? A character set. So maybe let's just add everything at once, I think. So, and I will discard those changes. Or maybe I will just keep. Okay, this I can commit all together. What do we have here? So basically this is our to-do list. We are working on this. Yeah, so let's just keep it. So I thought about discarding this, but I will just keep it in the dirty working tree for now. So let's just add everything what we did today. So the grammar, so we implemented create automaton, and just for literals for now, registries we will do later, and just a little bit of boilerplate. And here we just print them out. So we just create them and print them out. We have a lot of to-dos. We still need to figure out how to do this correctly. So maybe we'll write a few more words here. So words. How do I call them? So I call them literal tokens. So yeah, so I think I have the let's see. So we are working on sigil. I want to look at the specification. And I'm calling it, how is the add function called? Add literal token and add regex token. So turn literal tokens into NFAs. So literal tokens such as plus literal tokens so how do I say this? Tokens that describe exact character and protected such as plus if for keywords is like, but also, yeah, well, you could also imagine the Haskell operators, or if, what do we have, while, so for example, like this, I'm calling tokens describe an exact hected character string, literal tokens. So I'm calling them literal tokens. Those are now turned their corresponding non-deterministic finite state. So let's read it again. I'm calling tokens that describe. So we are calling tokens that describe an exact pacted character string, literal tokens. Those are now turned into the corresponding non-deterministic finite state machine. Yeah, well, so it's not perfect, but yeah, I think it is clear what I mean. So let's run it again and look at the finite automatons. So no epsilon here, but yeah, we require epsilon transitions. We will see this when we process regex. So I almost forgot to commit again. So where was I? Yeah, so today I discussed the overall structure of the next few videos, which I'm currently, I mean here, those steps, so I'm not repeating them now. And we started working on the first one, and now we can create finite state machine out of literal and symbols. Yeah, so I'm happy, and I will do some research, the logging things. Yeah, but until then, thanks for watching. I hope you like my mumbling and my coding. Yeah, I hope not too wild. I mean, yeah, if I'm in thoughts, I don't know if I can express myself very clearly, but yeah, that's why it's also why I'm recording those and have a look if I actually make sense. So only way to improve myself. So yeah, so see you next time. Thanks for watching. Bye.